Take note of that. Okay. Second problem with significant figures is the number 0. Sometimes we don't count it as a significant figure. Great. When do we count it? Well, got a couple of guidelines here for you. Rules of thumb. There's always exceptions. We're getting used to that, aren't we? Okay. If you have a 0 in a measurement and you're asked to count up the significant figures, here's some guidelines. If the 0 is in the beginning or it leads everything, you don't count them. So in this number, 0.00013, maybe it's meters. It turns out that these 4 zeros in front are just helping you identify where the decimal point is. You're not going to use those to say, ooh, it's really precise. No. The only thing precise here is the 133. There's only 3 sig figs in this number. So I forgot to mention the guideline. Again, it's just a guideline. There's going to be exceptions. One way to remember whether you count the 0 or not is if it's helping you identify the precision. So here, these zeros, the purpose of these 4 zeros is to identify where that decimal point is. Those zeros are telling you that 133 is a tiny number. It's 0.000133. Okay, so we do not count. Don't count them if the zeros are at the beginning. If the zero's in the middle, you do count it. That's kind of straightforward. Here it gets a little tricky. If there's a 0 that follows a decimal point, or in other words, you have a 0 after both a decimal point and a digit, you do count it. And again, go back up here to this guideline. Why is a 0 here? Okay, so we got 12.1 versus 12.10. Wait a minute. If this is telling me how many meters someone jumped, 12.1 versus 12.10, that's the same value. They've gone the same distance. 12.1 meters is the same as 12.10 meters. Same distance. What's the function of that 0? It's telling us that was a more precise measurement. We know down to, what is this, the 100th place in meters? Turns out that's centimeters. We know really precisely how far they jumped. 12.10, not rounded off to 12.1. More precise. So, hey, that's the function of 0. Give us more precision. So, yes, we do count it. This number has 4 sig figs. Whereas a 12.1 only had 3 sig figs. Yeah. Okay. It could be straightforward, but here's the problem. What about a 0 that shows up before the decimal point, but it's after the digits, such as the number 3,200? These 2 zeros are showing up before the decimal point, and they're after numbers. Or do we count them or not? Actually, I don't know. Some cases, some measurements, maybe there's only 2 sig figs, just a 3 and a 2. Sometimes all the digits count. The zeros, there's 4 sig figs, and there are cases when the measurement requires that you only use 3 sig figs because that's how precise the measurement was done. How do you know? You really need to switch to scientific notation, right? So get your calculator out, type in 3,200, hit the F to E button, or by hand. We need the format to be a number between 1 and 10, but not 10, a decimal point, and then some digits. So that's going to be a 3.2. And then we have to multiply this times 10 to, and then, sorry, I already made an assumption here. Maybe you want to keep all the zeros, or maybe you don't. So there's a couple ways to write your scientific notation. Let's start with this one, 3.200 times 10 to the, I need an exponent so that when I multiply this out, 3.2 times 10 to the something power, I have to equal 3,200. So what you can do is put in this place now, and then go back. Well, let's do it over here. I'll get a little messy. Put decimal place here, and then go back 1 spot, 2 spot, 3. Okay, I want to put the decimal point after the 3, and I had to move decimal place 3 positions. So this is a 3. And then I would check my answer. I would go to the calculator and say, okay, 10 to the 3rd power. Well, that's a 1 followed by 3 zeros times 3.200. Yeah, 1,000 times 3 is 3,000. 3.2 times 1,000 is 3,200. 3,200. Good. I converted correctly. And now, now that you have scientific notation, it's easy to count. This one has 2 sig figs. Whereas this one has 4. Nice. Okay. So hey, just made a case for why we might want to use scientific notation. If the number's not huge or tiny, a good reason is to indicate the significant figures. To indicate how precise the measurement was made. Ooh, we're done with that. Okay, last topic, rounding off. Great. If you've had a chance to do some science with other instructors in the past, you may have discovered a lot of people have different ways of rounding off. And chemistry is no exception. So for the most part, most scientists agree by these rules, and they're not so much rules, but more guidelines. You need to get some confirmation from your instructor as to how you should round off. If you go on to work in a research lab, you actually need to do statistical analysis to properly indicate the precision of your measurements. These are just quick little shortcuts. And that's good enough for us today. Okay, so if we have to do some calculations, which we will, and where's my mouse? There it is. After you do some calculations, we're gonna have to round it off to the correct number of significant figures, right? So if you put in your calculator, hey, I wanna cut 1 meter into 3 parts, 1 divided by 3, your calculator would say is 0.33333333333. Whoa, how many sig figs are we gonna use there? We have to round off. In this case, we just round off to 1 sig fig and say, okay, if you cut 1 meter into 3 parts, the length of that part is 0.3 meters. I would use the same sig fig. And I just evoked the second rule there. If you're multiplying and dividing, I just did 1 divided by 3, I divided. The answer is going to have the same number of significant figures as the term with the fewest significant figures. You might notice I like to bounce around. Let's go back to rule number 1. We'll come back to tool 2 in a second here. It's really important that you only round off 1 time. You may have heard of rounding errors, and that happens if someone does a measurement, rounds off, takes that number and multiplies it or divides it or subtracts it for something else, rounds off again, take that new number and does some other calculation with it, rounds off a 3rd time. Every time you round off, you're getting less and less accurate, and all those inaccuracies start to build up so that by the time you're done, your final number is really unreliable. Okay, so the rule here in science, again, check with your teacher. Most scientists agree you can't round off more than 1 time, and you're only going to round off at the very end of your calculation. If you have a series of things to multiply, add, divide, whatever, do it all. At the very end, you get the round off. Okay, and the nice thing will be, if the nice circumstance will be if you're only multiplying and dividing, because then it's easy. The guideline is look at your numbers, who's got the fewest, that determines the sig figs of your answer. So for example, we got 25.0 times 3.0 times 4.88. Punch that in your calculator. Calculator displays 366. What should we round it off to? Or do we even have to? Yeah, this is science. There'll be questions on the exam to say, report your answer using the correct number of significant figures, and you will lose a point if you don't get the right sig fig. All right, so how do you get the right sig fig? Well, let's count the sig figs. There's a 2, a 5, and a 0. Okay, the rule is if the 0 comes after the numbers and after the decimal place, count it. That gives us 3. This first number has 3 sig figs. We got 3.0. Again, the 0 is after both numbers and the decimal place, so count it. This one has 2 sig figs. 4.88, I count 3 digits there. There's 3 sig figs. And the number of the term with the fewest decides the answer's number of sig figs. So there's 2. So I only get to keep 2 of these, the 3 and a 6. Oh wait, but I have to round off. And so if the number you're dropping, the first number I should say that you're dropping is a 5 or greater, you have to round up. So it's not 36, it's 37. Wait, not 37, right? You have to change it to a 0. 370 is the correct answer, with only 2 sig figs. And if the teacher's saying, I'm going to give you points for the correct number of sig figs, and you want all those points, I wouldn't write it this way. I would write it this way. Great. Punch it in your calculator, figure out what it should be. It's a 2. So 10 to the second power is 10 with 2 zeros. Yeah, 100 times 3 is 300. That's close to 366. So 3.7 times 100 is 370. Nice. Tricky problem, huh? Another case for scientific notation. And if you thought that was bad, hopefully that's not too bad, right? Look at all your multiplying and dividing terms. Who's got the fewest sig figs? That's how many you keep in your final answer. Adding, subtracting, the rule's different, okay? It's all about decimal places. So the number with the fewest decimal places determines how many decimal places you have in your answer. Okay, so I got an example here, 0.147 plus. Okay, as soon as that plus showed up, double check here. Yeah, there's no multiplying or dividing. The rule changed. Let me ask a side question. How many sig figs here? There's 3. Okay, 1, 2, 3. Don't count the 0 before the decimal place. Why is it there? It's just locating the decimal. There's 3 sig figs. That's interesting, but not important. Not in this problem. We're adding. So how many decimal places? Well, in this number, there's 3. How about in this number? There are 4 decimal places. Right? So this last 6 is 4 positions away from the decimal point. There's 4 decimal places. This one has 3. You know what? And I'm counting these like that's helping. I guess it could. Here's an easier way to do it. Go back to elementary school and used to add and subtract, even multiply and divide, and do it vertically. All right, so I'm going to add 0.147 plus 0.0066 plus 0.012. Okay, and I put this in the calculator before I started the video. And the calculator is going to say, yeah, if you add these up, it's 0.1656. Okay, but the rule says the answer has the same number of decimal places as a term with the fewest number of decimal places. This one has 3, this one has 4, this one has 3. So all you do is just shave off everything here, right? So 2 of these numbers have 3 decimal places. That's how many decimal places are going to be in your answer. And yep, that 4th decimal place with the 6 gets chopped off. So I'm going to keep 0.16 something. That 6 is bigger than 5, so I have to round up. The answer is 0.166. And how many how many significant figures are in this answer? The zeros before the decimal place, don't count it. It's before all the numbers, don't count it. There's 1, 2, 3, there's 3 sig figs. So I can tell from this conventional number how many sig figs there are. I do not have to use scientific notation. Nice. Wait. Thinking there's a whole nother topic. No, there's just one more problem. Let's put it all to, oh wait, maybe I had to go vertical. Sorry. Yeah, go vertical, like solving addition and subtraction problems. There we go. Oh, I forgot about this part. Why is addition and subtraction all about the decimal place? Well, I was trying to think of an example to illustrate that. And here's one that came to mind. You know, suppose you're trying to lose weight by counting calories. And hey, you go look up a standard cupcake. What does that mean? Standard cupcake. It can be really big, really small cupcakes, whatever. All right, we already got a sense that we're not being very precise on how many calories a cupcake is going to have. Let's say it's about 300. Put the word about here. About 300 calories. All right, so I'm trying to lose some weight. Should I eat that cupcake? Oh wait, look what I did here. Took away this one candy. This one's gonna have fewer calories. Maybe it's okay for me to eat the one on the right and leave alone the one on the left. I can still lose weight, right? No, really, these are about the same. It's still about 300 calories. Well, that's the answer scientists would think, right? If you didn't know this measurement very precisely, it's around, I would say 1 sig fig, 300 calories, and you take away one candy. How much is this candy? 5? 10? Well, let's say 15. So where's my decimal place? It's over here. So I add these up and I get 285. And it looks like I got 3 sig figs when I said, you know what, I'm only comfortable saying there's only 1 sig fig. That's not right? How do we get more accurate by taking away a candy? The cupcake's around 300? I don't know exactly. 1 sig fig worth of precision. If I take away candy, well, it's 285 mathematically, but I'm still going to round this to 1 sig fig and say it's still around 300. Right? And so look what we did. We kind of kept the decimal place. Even though I subtracted something, yeah, it's not going to help you stay on your diet. It's not really going to matter in terms of precision. I hope that helps. Trying to make a case for why we're only following the decimal place here. Okay, let's end this video with as complicated a problem as you'll see on my exams. So it will not get any worse than this. And if you encounter this, you'll know how to tackle it. What are we going to do here? We're going to use all 3 rules in one problem. So let's see what we got here. Problem is 1.589 times, okay, the rule for times, so multiplying is number of sig figs, and the answer is the same as the term with the fewest sig figs. Yeah, but in parentheses here we got addition. Addition's rule is the answer has to have the same number of decimal places as a term with the fewest number of decimal places. So what do? Go back to rule 1. You can only round off 1 time, and at the very end. So my advice for you is, do the problem twice. Hey, sorry, that says twice. Yeah, do it twice. What I mean by that, it means first time, be really particular. What do we have to do first in terms of order of operations? That's a plus. Well, do the parentheses first. So step 1, I need to add these together. And if this is the only calculation required, I would keep the fewest number of decimal places, right? And I would do it vertically, 1.4. So you add this up, that's a 4 and a 5, 24.5. I would say, okay, this one only has one decimal place. The top number had 2. I need to shave it off here. So this would be the number I would report if I'm all done. I'm not all done. Okay, that's all right. We're doing the problem twice. First rule says keep the number of decimal places as a term with the fewest decimal places. This only had one decimal place. Can only keep one decimal place. So my answer would be 24.5 if I was all done, right? Because I just rounded off. Okay. So we're doing this twice. Step 2. 24.5. What are we going to do with that? Sorry. Go back to the problem. It's 1.589 times the answer inside the parentheses, which if I were allowed to round off, I'm not, but if I could, it'd be 24.5. And then I would tell the calculator, hey, I need to get an answer here with how many sig figs? Well, it's multiplying. That rule is count your sig figs. Fewest sig figs win. So this number has 4 sig figs. And after I round it off, this only has 3. And the answer then has to have how many? 3. 3 sig figs. Okay. To get the right answer though, don't put it in your calculator, because you would have to get this answer and round off a second time. You're not allowed to round off a second time. So what you have to do is start all over. Okay, so round 2. Second time, we're going to start all over, knowing that the answer has 3 sig figs. Okay, so the first time we did it, that was just to figure out how many significant figures it should be in our answer. Second time we're going to do it, we're going to say, okay, the number is 1.589 times, in parentheses, 23.14 plus, 1.4. Well, get the calculator out, or trust my hand addition over here. If you look at the calculator, it will spit out 24.54. Now multiply these numbers together, and the calculator, I got it written down over here. At least I thought I did. There it is. Calculator says 38.99406. You can lose points. You write down all those sig figs. Now we found out from step 1, you can only keep 3. Gotta cut it off right there. Oh, so that 9 is bigger than 5, so round up. That's 9 goes up again. So the correct answer is 39.0. Whoops, let me exit out. There you go. I hope that helps. We've taken a look at scientific notation, significant figures, and finally rounding off, taking into consideration significant figures. That's all for now. I'll see you later.